for the dry material, for the fresh cassava. But in the South Africa or West Africa, mostly the ratio for the cassava is around 20 to 25%. And based on that, we have the different output. For example, if you have the 27% of the cassava starch inside of the cassava, we will like 4 times, nearly 3.7 times cassava can produce like 1 ton of the cassava starch. So mainly we depends on the ratios inside of the cassava to get the output for each. So and also one knowledge is when you put the cassava under the ground and let it grow 2 years or 3 years, based on that, with the time increase, the ratio for the starch inside of the cassava will increase. Mostly can increase about 35 to nearly 40%. So for that one, nearly 2.5 or no more than 3 tons can build 1 ton of cassava starch. So my suggestion is, once you have a cassava tuber material supplier, you can check the starch ratio inside of the cassava and to get the output and calculate your interest. And secondly, we go to the dry sieve. And the dry sieve and the roastery washer, or basically we call it paddle washer. These two machines is to clean the cassava, because once you get the cassava from the soil, some dust and the soil will on the cassava. The first step in the dry sieve will mainly to take the little stones or the soil and everything outside of it. So once we take it outside it, we turn to next step is the rotary washer. And for that one, we will do using the water to wash the cassava. Because in the next step we want to clean, we want for the starch material and the starch quality, we don't want the cassava bring too much sand or the soil to next step, because we need to clean all of them. Okay, let's go to the belt conveyor. Once the washer is finished, wash step is finished, we use a belt conveyor to bring the cassava into a cutting machines. Because for the cutting machine and the rasper, these two are one step. We are calling it breaking step. Because cassava is too big for the rasper, we need a cutting machine to cut it into small pieces and then bring to the rasper to do the rasper to mill it. And after the mill into the cassava milk, we bring the cassava milk into the centrifuge sieve. And the centrifuge sieve is both centrifuge sieve and the fan sieve is to guarantee one thing: we need to bring the fiber outside of the starch. After these steps, we go to the hydrocyclone station. In the hydrocyclone station, we are taking only the starch out, which means all the other things like the proteins and the other things will all be gone after the hydrocyclone station step. So both the hydrocyclone station step, we use a soft water because we need the water to inside to wash all the machine, wash the cassava starch. It is like this. It's opposite way. is the cassava starch going in this way, and the water goes this way. The soft water goes this way. It keep wash the rest thing out. It only take the pure starch to outside. And then it's a drying step. The drying system. After the drying flash dry system, we do the final products, which will be the cassava starch. So let's see the 3D videos and the 3D photos for now, and we can show you here a video for the starch. Wait a minute. It's still like this. The cover. Let's see the video. Firstly, this is the hooper, and the hooper here is to put the hooper inside. You can see. Let's see the machines first. After the machines, we can see the rest. We got the hydrocyclone station, the pillar centrifuge, and the others. Like it bigger. Bigger is better. Okay, great. And this one is we put the cassava into the tubers, and from the belt conveyor into it will inside of the dry sieve, and after the dry sieve, to take the dirty dirt out, we will put the things into the paddle washer to do a second cleaning, and after the cleaning, it will go to the paddle washer, also a belt conveyor to bring them to the other step, which will be in the cutting machine in here. You can see in the cutting machine it will cut it into small pieces and go down to the rasper, and this step is to help the raspers to break it. Now here is a conveyor to drag it. Usually, let's see in here. Usually, this conveyor is, we call it, it's a set quantity conveyor. It's for each of them, it set a maximum quantity, which will help the mill machine to do the job. Because once you put too much cassava into the rasper, it will start. Firstly, it will start maybe stuck the pipe down here, or the main thing is it will light the electricity too much. For this kind of rasper in here, usually 45 kilowatts or no more than 60 kilowatts. If this machine do the full process, it will the ampere will go to nearly 180 to 190. If too much, it will break the roof to 21 kilowatt, 21 ampere or 22 amperes. If it's too much, it will be hot and it will damage some of the machines. So we better so we cite this set quantity conveyor, and let's go to next step. Here you can see this 5 is dynamite thing. It will take the, when you put the cassava have maybe a little bit the iron or the other thing is magnet, and it will take it out and help the machines to run. Because once it come out, the raspers, they have a lot of knife inside. It's run very quick, like 1200 round per minute. So once a iron go inside or little stone go inside, it will break all the knives inside. So we must be very careful. So this is this magnet do, and before all the machine the pedal washer do. So and maybe in this step,
有买家进入直播间了。
and in this step, here there is a stage going up. This stage going up is for like when you see there are some of the stones on the belt conveyor, or see a very long wood or something else. You must arrange somebody to take out from it. Okay, let's keep it going. Yeah, this step, let's keep it going. Once you rasper into the milk, it will go down to a pool, and in this pool, we will use a screw pump to pump the milk to another step. This is one is a screw pump. It will build to the centrifuge sieve. In the centrifuge sieve here is using a water to clean the
有买家进入直播间了。
Once some of the starch will go outside from here, and the other step is for the fiber, and some of the starch will go to the second stage, and in the second stage it do the same thing and go to the third stage, fourth stage. Usually for this one is called fourth stage or fifth stage based on the quantity and the capacity. If the capacity is very high, you will need at least 4 or 5 to do things. But if your capacity is smaller, maybe 1 or 2, maybe 3 is totally enough. And remember, this step is to prevent the fiber go out to go next step. So mainly this step is take the fiber out. Because in the standard, no more than 0.1% of fiber is allowed to do in the final starch. So this step and next step usually to forbidden the starch, to forbidden the fibers go to next step, go to the hydrocyclone station and other step. So this is, you can see here, this one is go to the fine fiber machines here. This step is also to prevent the things go outside. Like once you take the things, it will drag and keep the fibers go outside, and bring the starch with other things like the proteins and the other waters will go to next step. It will go into a middle tank. You can see here in the middle tank there is a motor in here. You can see there is a motor, and in this motor this thing is to go in stir all the time once you have the starch inside. Because if you take too long and put the things in there, the starch and the other part, the dry part, will go down, and it's hard to get it out. So we must stir part inside to keep stir, and light the starch with other part with the waters. They mix together to light the screw pump to take to the next step to the hydrocyclone station. Let's go. This one is called desanders. This one is a desander. We use it to forbidden the sand going inside to the hydrocyclone station, which means this one can do it before the hydrocyclone station or do it before the fine fiber is both okay. And in this hydrocyclone station, because hydrocyclone station, it's a lot of hydrocyclone pipe inside, and the starch will go to the small pipe, and the other things will go to the bigger pipe. So it will do like this. Yeah, you can see here. Once it go here, go ups. The starch will go that side, and the other things will go that side. And there's a many pipe inside. So you can see it's separate. And the starch for this one, the brown one means other things like the proteins, maybe a little bit of fibers, the waters, the sugars, or something. It will go this way, and the protein, the like starch will go to this way. It will go moving to forward, and the things like this. So basically, we're doing a test before. If you want the machines to produce like over 94% of whiteness or more, no matter how much the capacity is, we must have like over 94%, over 18 stage of the hydrocyclone station to get the 94% of whiteness to fulfill the best quality. And they are nearly doing all the same thing. Is to clean it step by step by step by step to get pure starch. And it's one by one by one by one by one. Okay, after the final stage, it will go into the it's go another middle tank. You can see also it have the stair inside. It's put into a, it's called high can, something like that. It's a high tank. It's using, there no need a like a screw pump to take the things to the pillar centrifuge. It's like the way to do the job, and put to the pillar centrifuge. And the pillar centrifuge is very good. And for this one, after this step, usually you can get a percentage like 36 or 38% of the moisture. So after this step, it's pure starch but a little bit white. So the starch will be separated by each other, and you can directly use a belt conveyor to take to the next step, or you do a like the conveyors to next step. Both are okay, but we suggest not using a conveyor. It's better because once you put once the starch put in too much with air, it will be brown. It's a exchange hot exchanging here, because usually for this is a flush wire system. Mostly we use a boiler. So the boiler, the hot air will go inside of this pipe. Steam will go inside of this pipe, and there is a exhaust fan here.
有买家进入直播间
It
了。
will drag the hot air from this part, the exchange thing, hot air exchange thing. It will go inside the pipe to drag the starch over from the beginning to the end. So it will be like this. Yes, it will be kind of like this. The air is dragged from the outside to the inside. So the pressure will be negative inside of the pipe. So it's a forbidden starch going everywhere, because you can see when we put the air inside of the pipe, to push the air inside of the pipe, the pressure for the inner is bigger than the outside. So once we do that like that, with the pressure pushing the starch, the powder will go outside of the pipe. So doing the negative pressure will help doing this. Okay, and go into the hydrocyclone station. Not hydrocyclone, forgive me, the cyclone. After the cyclone, it will go into a like to put in the conveyor, and the conveyors will bring to the, it's called a cooling system, because after the flash dryer, usually for the steam we're using a 7 bar, but about 7 bar, which means the pressure will be the temperature will be around 180 degree to 190 degree. So for that one, the steam is like this, but the hot air inside of the pipe is maybe around 75 degree or more, maybe 90 degree or 120 degree, to take the moisture inside of the starch to outside. So once we pass, the destiny temperature is nearly 45 to about 60%, 60 degrees, around here, or less, maybe 35 or something. So we must have using a cooling system to take the water, take the temperature down, and you can put it inside of the packaging. Okay, once it's finished, it will go in a cyclone, and after the cyclone, it will be a can inside here, and to put it down to a safe in here. And all the job is done. There's a packaging machine inside here, and you can do it. You can packaging, do the automatic packaging and sewing here, and it's ready to go and ready to sell. Okay, let's back to close it and back to, let's see, we already passed the 3D video in here, and this is some screen print for the last videos, and to show you for each step of each step. And this is some of the flow chart for the we've done it before, and this is we can here, let me doing bigger one. Right here. Oh, not good. Okay. Okay. Let me do it bigger. Yeah, here you can see there's a forklift to take the cassava into a cassava hooper, and after the hooper there will be a belt conveyor to take to the dry sieve. Here is a dry sieve. You can see there is a to show you the going to where. This part is when you have the soil and stone and something, it will go downstairs to so this one is higher than the ground. We usually put it above a stage, and on the downstairs we take using someone to clean it, because it will be a lot if you don't directly take the cassava out from the soil and don't do any clean, it will be very dirty. But some of the customers or some of the hi there. So once you take the things out, it will go to the pedal washer, and this step is purely to cleanse all the dirt out. So because we not like the cassava flour and the cassava flour and Gary. The cassava starch don't need to take the peel out. Don't do the peel, but before of this, we must clean the cassava very clean, and then after cleaning it, go to another step. This one is you can see here. This one is the cutting machines. After the cutting machines, it go to a screw pump, conveyors, and the conveyors will go down to here. This is 2 raspers, and finish the raspers, they're going to a pool. After the pool, there is a screw pump. Here you can see the screw pump is taking the things to here, and it will go to the next step. And here, from the inside, this one is a starch, and finish the first stage, it will take out, and some of the waters, and a little bit of the starch will go to the second stage for the centrifuge sieve, and to the third stage and fourth stage. Once it takes the water out, take the starch out, it will be back to the first stage and take the starch out, and pass the fine fiber sieve. This step, the fine fiber takeout step, is finished, and go to the next step. Then here is a like the desander. After desander, all the fiber and sand is taken out, and when let the other things go to the hydrocyclone station, and we can count it here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. After 21 stage, this hydrocyclone station are doing only one thing: to take the starch out of the water. So after that, we will do a pure starch. It's without any proteins and the sugars and other things. We don't need that. We only need starch. Okay. And this is the final step. And after the hydrocyclone station finished, it will go to a middle tank in here, and the middle tank will go put the things directly into the pillar centrifuge, and voila, all the things finished. And here is also a step by the flash wire. It's kind of, you put the starch inside here. It's a winnower to take this in here. It's using a it's called a high and low conveyor step. It's with a higher conveyors on the high side, and the lower conveyor on the low side. It will have gravity. Based on gravity, it will go by the things inside. So no need a winnower in here, so it can go much better to the flash wire, because we need to give a flash wire also using a gravity, and to spread it into a pipe, or like this, it directly light the cassava starch using gravity to go down, and light the air, bring it back to the flash wire. And after the flash wire, there will be 2 sieves, and one sieve. Based on the quantity and the capacity, we may have 1 starch sieve or 2 starch sieve. It's only based on the capacity. Okay, and then going to a automatic packaging machines. Okay, let's see some of the machines. This is the hooper, and this is what I call it a set quantity conveyors. So for this one, is set of each step. There's a lot of step by step. It's a little bit of space. Only have that much cassava starch, cassava inside of it. It will forbidden too much of the material go to next step. Yes, avoid the ampere going too high, and it will lead some damage to the machines. And here is a belt conveyor. And let me find you some of the and and these are some of the machines. We put it into the container. This is also the belt conveyor. This is also the hoopers. Wait a minute, it's a small hoopers. It's not look good. Look like a trash can or something like that. But you can see our conveyor, the hoopers are very strong to take the things. And this is the thing we built into the conveyors. Machines. This is how we made it. Yes, it's how we made it. And the conveyors. Okay, the conveyors. The belt dryer. Belt dryer is not in here. Yes, it's in here. And this is we call the three parts. It's in here. It can hold the cassava very stronger, and it will not let it to go too far away, because before we only put one on that one on the one row in here, but now we take it back to three. All the things we'll put the things inside of the belt. It will not let it go around too much. And here is the things. It looks like it will drag the machines. You can see here, it will drag the cassava and give a lot of power to move to drag the cassava to next step, even it's a little bit wet. Okay. Okay, we're back to here. Back to here. No. Back to here. It's a conveyors here, and it's using to transfer materials, and there's 3 or 4 stainless steels to fulfill your require for the food grade processing require. So here is a dresser. It's using to take out the sand, the skin, the fibers, maybe outside things to do the better cleaning things. We do a lot of steps to do the things. So in each step, we are taking, for these things, we are taking to let the soil go downstairs, and that's all we do. And for this one, for the dresser, we do have the machine. Yes, these are some of the machine. We've done it before. You can check the machines. Yes, looking at it is inside. This thing, you can see the circle by circle like this. It's push. When it go around, if we don't have this thing push, the cassava go directly give it a directions. The cassava will turn round in the can. But when we put these things on, like these things on, it will give it a direction and let the cassava into next step. And this is kind of like right now using a big chain on its motor on the inside on upside. When the motor working, it will using a chain to take it to turn around. Okay, these are the machines. Let's go to next step. It's about conveyors. This will be the second stage, and for this stage, let me show you some of the videos or this is the build conveyors, and you can see the pedals inside. It's looking like this. It will be, and here is the stones. There may be a lot of stones going inside, so let with the gravity, because the small things will go. Okay, finish. The small things will go upstairs, and the big things and the heavy things will go downstairs. So the stones will go to the smaller. We take a hole only for the stones, and for the other because during the process of the pedal washer, it definitely will take some of the first skin out. And we must have to clean of these things, so it will help us clean this material. And we can see during the video, you can see one interesting thing, because we also the pedal washer will look like it's like this. Yeah, the pedal washer goes in this way, and it will continuously going here and turn around to here. So we will put something clean water from here to reverse to clean the thing, because once you go in this direction and the water going in this direction, it will clean better for using less water to do a better clean thing. And this one is the cutting machines. After we clean it with because it's not quite potential for a if you see it's a real cassava. Firstly, it will be very big. It's like this one. We do see something much bigger than this one, but usually it's like this one or this one. But it's not kind of like a circle. It's more than, it's very look like weird things. So based on that, we must cut it into small pieces and let the rasper do the work to mill it. So we use made for the 304. Firstly, we use 304 stainless steel to do for the buildings, and for the knives we're using 4CR13 material to do the knife, and it will be the blade is more and it will be much stronger. Okay, keep going. Here, keep doing. And we can adjust, because when we put more blade inside, the cutting pieces will be smaller, if you can understand me. So we can adjust that. So we do have a standard for this one, but if you have quite suggestion, or if you think we must let the pieces be as small as possible, okay, we can add more blade inside. This is a magnet thing. With the magnet, it's using to protect the raspers and don't let the iron inside, and do the things to protect the knives inside the raspers. Okay, to the very important thing is the rasper. It will, because the raspers, this one is running a lot fast. This one outside here is to take it to run the machines inside. It will like 1,200 ampere per minute. It will go 1,020 times to cut the cassava. We put it downstairs, so it will mill it inside the thing for each of the knives. It will be like 0. Or nearly 1 millimeters or 0.5 millimeters for each of the knives. So it will cut it's more than, it's like cut and scrape the cassava and drag it into small pieces and being very, very thin. Why we suggest the customers using the raspers is thin, because once we break the cassava more, the cell of the cassava will break more, and if we break more cells, the more starch we will get. So using like the raspers with the breaking rate will raise to around 14 or not 14. Sorry, it's more than 94% of the breaking rates, or 94, 95. So more we mill it, more starch we will get. And here we're using a 65 mol material, and if the thing's broken, we can turn around and reuse it. So we will set a thing for the conveyor to bring the things inside. To like I said before, we will set a quantity for the conveyors, and like the conveyors take no more than for each step we must no more than like 500 kilogram, and not for 500 kilogram, like the 50 kilograms each step, and no more 50 or no more 40. It's too forbidden. The ampere is too high to burn the machines. And here is small knives. This is a small knives. In here you can see each of this small knife is very, very small. Now you see why I see it's more look like a cut and then scrape is getting it. Okay. And this one is safe. Let me drink some water. Centrifuge safe. You can see here, this is the fiber. This is the starch. We put the things into that, both starch and fiber inside of the centrifuge safe. After the centrifuge safe, the water, we will put some water inside of the machines, and with the waters, and it will circle around. Then the starch will go out, and the fiber will, because the starch will pass the sieve. There is a sieving screen inside of it. We pass we push the water with the fiber and the starch. We push to the sieving screen, and the starch will go outside, and the fiber will remain and keep it on this side. So it's using that of quantity to do the same thing. And we're using 4 stage. You're already using 3 or 4 stage, or two or 3 stage. It's also okay, because I was going to the Ivory Coast on a project, and they do like 3 stage. It's also acceptable, but you will make a little bit starch waste. So we suggest to do more than 3 or maybe 4. But based on the quantity, if the quantity you do is very low, maybe 1 or 2, even directly don't use it using a fiber stage, the fan fiber is also okay, because based on each of the quantities, design for the machines and the design of the process will be totally different. So we can do it. It's called a horizontal centrifuge. And this is desander. We are to take the desander out of stage, to promise to get the high quality cassava starch, and it's to take it uses 100% stainless steel, or sometimes using other things, but not use carbon steel. It's using I forgot that name, but we can. If you have interest, you can contact with us, and we will send you the pictures, and you will see. And to take the sand out. And this one is the hydrocyclone station. It's mainly to extract and pure the starch from the starch milk. So we take the proteins, the fat, the cell, all going out. Only takes the pure starch, because each of the heaviness for the cells and for the starch and for the fats, they are totally different. So we are when it's more, because in this step we are not taking the lighter thing, we're taking the heavy thing, because starch is because it's a dry thing. It will be heavier than the cell, than the protein, and the fat. It will go downstairs. So we're using the 18 stages. First 4 stages is we directly go to the 4th stage to do the first extraction, and to the 5th we do the second extraction, and there some of the starch will go with the protein and the cell. So the first 1, 2, 3 stage of the hydrocyclone station, we are taking the starch back. And the 8 to 18 is to clean and wash it to get the pure starch. And we will return it back from 6th and 7th stage. We call it the extraction return. And we are using better using soft water to do the project, because if we using a pure, like the water from outside, or from the river, or from the underground, it's not clean enough. So we must using soft water to do the things. One very interesting question, because and one interesting examples, because one of our customers keep asking why our the whiteness is no more than 94%. It's very low, and it's about 85 or 86, something like that. But after changing it into soft water and rewash the place, rewash the machines, it's back to 94%. Even more, it's about 95. So it's a miracle, and that's why it's very important to using a soft water. And all the step connection and the pipe is using 304 stainless steel and food grade material to keep the quality for the Cassava starch. And we are using something is not bright stainless steel, no more lighting pollutions, and something using nylon 66 is also food grade. And but we need to clean this pipe maybe 1 or 2 months. We need to clean it once. And here is the pillar centrifuge, and using the pillar centrifuge, each step will get about 35 to 38% of the white Cassava starch. And it's like this. The principle is like this. We put the water inside the things, and like the starch is all inside, and it will roll. We usually think it's more than 910 G, giving them that power to let the water outside of the machines and outside of the starch. And after that, we're using a peel we call the pillar centrifuge. We're using a peel to scrape it out. Yeah, it's called. And after we take the machines, we're using a water to recircle the sieve and to promise the things. Usually we have 2 steps. One is using a normal, one is using to drying things. Each step of the drying process it's time by time, 3 or 4 minutes, one part. After 3 or 4, maybe usually 150 kgs materials go inside, using 3 or 4 minutes to finish all the all the water out. And after re-put the material inside, and using another 3 or 4 minutes to finish take the water out. So it's something like that. And usually the moisture for the machine for the starch will be nearly 38%. That's why we do have a customers come from the Ivory Coast and trying to get this thing, because the moisture after they're using a very weird thing. They're using a hydrocyclone station, but only 4 stage, and you add a decanter. So after that, the moisture is nearly 50%. When it's going to the flash dryer, it will be not enough, and they're using not flash dryers. So right now they are trying to do a pillar centrifuge after the decanters. They have to have the 50% of moisture, and you add more water to like a 22 BE, and then put it back to the pillar centrifuge. And after the pillar centrifuge, the moisture will down to 36% and back to the flash dryer. It will be much better. So the last part is the flash dryer. We're using the negative part thing to do. It means the exhaust fan is in the end of the process, and it is using exhaust fan to drag the air from the pipe. So it's the pressure is negative inside of the pipe, the dry pipe. And the thing is, it will not. The good thing is, because the pressure inside is smaller than outside, so the pipe starch will not go outside. It will avoid this part, because some of the factories, they are in the starch part, if they using positive pressure process, so it's going everywhere. I have to say, the starch will be going everywhere, like here. here or inside of the factory. If you do the positive things, it will cause this bad things. And we do have because I was joining a project in the Kinshasa, and they do like these things. They do like a control by PLC. On the computer, I can see one thing: they print 3-degree detectors inside of the flash wire. The first is from the exhausted from this step, the exchange rate hot exchange place. We do have a detector in here, and one of the detectors is in here in the middle of the pipe, and one detector is in here in the last in here. They are taking 3 steps to control the air, the hot airs inside of the flash wire to avoid some damage. So, and we can control the inside of the material and also control the air quantities. So, and it can better control the temperature and to control the stable water inside as a stable moisture for the cassava starch, because it's kind of like this. We are in the name of the factory, like the producer factory for the starch. If the moisture is too low, because if the moisture is too low, the quantity, the output quantity, will be short. So it's like this. Because the standard of cassava starch is 14% of the moisture. If it's too hot in the pipeline, in the pipe, the moisture will decrease to like 13% or 12%. So you will short like 2% of the quantity, and it will lose some money. So we better suggest to using a detector to check the temperature inside the pipe, and to like 30 or 1 hours to check the moisture from the starch for the output starch, and then to control the temperatures inside of the pipes to avoid these things. To no bigger than 14%, but don't go too low. And this is a safe. This is a safe. We are using to shake the starch to go downstairs, and to go to the cyclone, and here is the automatic packaging machines, and that is the PLC, the computer control system. Here is the CCTV, and you can check each step. We put the cameras and the monitors all around the factory to check each step, each machine, how it works, and everything. And we do have a program and to control, to stop and run for each of the pipes, each of the machines, to do it automatically run or automatically stop, or something emergency happens, we can maybe using one point to shut down all the production lines, and to monitoring all the details for each of the project, each of the machines, the temperatures, amperes, the pressure, and the kilowatts. We can inspect all of the things, and it's also better for the factory to control each steps and to avoid the dangerous, and to control the project. Yes, these are the PLC working like this. You can see when the red light means it's shut down, it's green light is working, and we maybe click this button, and it give you an option to close it or still do working it. And all of them are PLC. So it's all finished today with all the PPTs and the centrifuge things. So if you have some questions, I can give you some answers. If not, we can cool to turn it off. So any questions from now? If yes, please let me know. If no, we can close it. So thank you guys for watching. If you have some questions, you can directly contact with us and to get more information. Okay, bye bye.